We are live. So, welcome again, Ayush. And
Thank you, Piyush.
I the last conversation we had was like I think what 8 months or 1 year ago.
I think until over
Something.
1 year now,
Yeah,
might be.
over
Yeah.
1 year. So, also this is a different channel than the previous one. So that's another thing.
Yeah, yeah. Lot has changed.
Lot has changed. Yes, yes, a lot has changed. So I'm going to give like a quick introduction of you, and then you can take over, just so that
Sure.
any of the new audience members can relate or have like a sense of where you're coming from.
Mhm.
So, well, the first thing is, I and Ayush have worked together, so that's like how
Yeah.
we know each other. And well, Ayush is from computer science background. Then he worked at Texas Instrument for some time, embedded
Mhm.
related project. I'll let him speak to that.
Sure.
But then he came over to Google, worked there for like a year and a half ish. Then
Yeah.
moved to ARM, then worked there for some time, and then now he's
Yeah.
at Apple. And
Yeah.
in terms of the technical background, then there have been DLPs involved, then power
Mhm.
management involved,
Yeah.
GPUs involved, and I think the
Yeah.
current project is also GPU.
GPU, yes.
Okay, take
But
over.
very, very different beasts from what I've been doing. So, yeah, I mean, I think let's start with computer science. Yes, more computer engineering than computer science,
Hmm.
but it's basically a few electronics and architecture stuff thrown into computer science as well.
I see.
Most of the graduates from my class actually did go on and become like computer scientists and working in pure software jobs.
Nice.
So it's mostly
Nice.
computer science output, even though it's a computer engineering field. So I, on the other
Yeah.
hand, got
Hmm.
into a
Hmm.
very core field for
Hmm.
computer engineering. I went into embedded, which is the target, I would say, biggest
Okay.
target for computer engineering that there could be.
Right.
And with the modern landscape now, I imagine a lot more people from like my
Ah,
course would be joining embedded than software
sure.
engineering.
Sure.
Uh,
Is it because of
but yeah,
Nvidia and
I think it's a whole lot of things. Suddenly, in the last, I would say 3, 4 years, everyone just decided they want to do things on their own.
okay.
Like initially, embedded industry was more like, hey, we'll buy servers from you, we'll rent them, and we'll
Hmm.
sell it on to someone else, or
Hmm.
we'll buy phone chip from someone and
Right.
make a phone out of it and sell. And then suddenly, Apple came along and they're like, hey, we're making our own laptop CPUs, we're making our own SoCs, not even CPUs.
Right. Right.
We'll make our own phones SoCs. We'll make our earbuds SoCs. Apple's like, we'll
Right.
do everything ourselves. And then the whole industry went, hey, we are going to do that. So all the setup to build up all those SoCs
Right.
are getting copied over in every one of these big
Right.
major companies. So yeah, the input increases. So you need more hardware engineers, you need more software engineers, you even need even more embedded software engineers who can
Yes.
kind of become a bridge between the two. And that is not just limited to these products now. Now, if you look at AWS, if you look at Google Cloud, if you look at
Yes.
Azure, if you look at there's so many companies now building cloud and they're not buying like Intel chips or AMD chips. I mean, they are,
They're
of course,
building.
because they need to keep
Yeah.
their
To
diversified portfolio
right.
and they
Right.
want
Right.
to, give out different kind of products to different kind of needs. But they are building those themselves now
Right.
as well.
Right. Right.
So there's another industry that's spawned out of it where you need embedded engineers. So it's a huge push in the last 3, 4 years, I would say,
Right. Right.
that has come along.
It just reminded me. So the car industry is now majorly, well, it's trending to
Yeah,
become EV, heavy.
yeah,
So that's embedded compute right there, like embedded
yeah,
engineering. Then, as you mentioned, the cloud server providers, they need someone to run the servers and do the
yeah.
hypervisor stuff correctly. So, well, you need
Hmm.
embedded engineers there. And now things are AI heavy. So, well, you need people who can
Yeah,
program the GPUs and the TPUs on the
yeah,
servers, so more embedded
yeah,
engineers. Uh, and then I also was briefly reminded of this. So each company is more or less building their own chip for something. So
yeah,
I believe Tesla is building the Dojo for the AI compute on the
yeah.
car. OpenAI in between had jumped into that. We don't know what they're up to, but well, they're doing. Meta was doing the the AR headset, the AR
Meta,
VR
I think,
headset.
keeps shifting a lot. They
Oh,
are
let's do
doing
that.
AI on chip, they're doing AR on chip, they're doing, I don't know what else
Everything on
they're
chip.
doing, honestly. They want to do everything, I think. So, I mean, it's an industry joke that Meta kind of want to do everything, but I don't know what exactly they're doing, to be honest. I'm
Well,
not there. So.
at least the folks in Bangalore, from what I can tell,
Mhm.
they are doing the network on chip thing.
Right.
Well, network on chip, or well, not network on chip, but the network speed up related something.
Got it. Mhm.
Yeah, I don't know the exact detail. Relates to servers, relate to high bandwidth something. There
Right.
is networking involved, and that's what I know. Anyways, cool. So now let's go back to your story a little bit. So
Yeah.
computer engineering. By the way, I did not know.
Yeah.
I remember you having told this to me, and I'm sorry, I forgot.
Right. Yeah. I
But
mean, it's such a niche thing. Yeah.
yes, because
Yeah.
I recall what was well, never mind. Let's not go there. But what I recall is you mentioning that it's like a proper mix of electronics and computer science and like EECS, so to speak.
Yeah. Yeah, you could say that. It's basically so how our batch was offered the course was mostly they would have some, so they didn't have a computer science field per se. So computer engineering was technically their offering into get
Ah,
for
I
getting
see.
into computer science. So they had a lot of courses which were tailored towards computer science. You had your normal OS, DBMS, memory management, all these kind of things were there. Like you also had like SQL and all this, and memory
Right.
management comes in there. Anyways, database management. And so these were already there. And
Hmm.
then they had an electronics branch separately.
Hmm.
And they picked a few courses from there. So your basic electronics, your signal processing, and
Hmm.
everything. And then they picked from I don't know, from a country far, far away. They had the compute, computer system architecture, computer system
Ah,
organization, all
nice.
pulled
Yeah.
into one. So it
Hmm.
kind of felt like very tailored towards getting into embedded. I think it was, since it was a bachelor course, it was not very OS heavy as
Hmm.
I would have liked it to be. I
Hmm.
imagine, I don't know how the modern course that is being offered now is, but I would imagine they would have it more OS heavy now, because if you think about it, the OS requirement for embedded, where you're coding things in Linux or Unix
Hmm.
or whatever, is far exceeding now than bare,
Dan, yeah.
even though there is a lot of bare metal and there are a lot of RTOS
Right.
based systems as
Right.
well. I would say a lot more work is now getting done
Right.
on the kernel level or the user driver level there,
Right.
even for embedded systems. So yeah, so
Hmm.
this course which I did was kind of an amalgamation of all these three things, which kind of actually sets you up really well for a career
Hmm.
in embedded,
Hmm.
I would say.
Right.
But interestingly enough, me being a very naive student, I didn't even know why I was learning my 8085 microprocessor. Why computer system architecture was one of my favorite subjects,
Hmm.
but I didn't know where I could apply it.
Hmm.
I had no idea. So much so that I did all my lab coursework in Java, and not in C or anything else, right?
Nice.
So,
Nice.
and they allowed me to do it. I mean, you can,
Yeah.
if you can
Fair.
get the output correctly, who cares?
Right.
So when the first job that I joined, which was Texas Instruments, and we were in their projection technology team, kind of,
Hmm.
which is called DLP. And that is when I think I talked about it in the
In
first
the
one as well,
previous,
where
yeah, yeah.
that's when I got to know, hey, embedded is a field,
Field,
and
yeah.
my studies, everything has been gearing me up all the way to get a job in this,
Right.
and that I need to use C very extensively.
Hmm.
And yeah, it was a very big shock and culture, but I'm glad it happened to me. I mean, I'm glad I went into embedded. But yeah, it's one of those things that I never thought about, because I was doing web development, app development as
Right.
extra projects. I was trying to get internships and startups to build their applications or websites.
Hmm.
Um, and then I got into a big corporate job, and where I just had to see, and I had no idea how to do it. I had no idea how to talk to hardware. I had no idea what kind of
Right.
hardware technologies or the schematics that I will need to deal with. I
Right.
had no idea these
Right.
things existed.
Right.
So it was a very big, very fast ramp up to all these
Right.
things. Even though my coursework was supposed to teach me that, because I never thought I will be in this industry, I never did it correctly. So
But
yeah, that first job was a very good introduction to the merit for me, actually.
nice. And then I recall that this was during the around the COVID time frame. Then you were
Yeah, I think I joined my first job in 2018, so
okay.
I still got good 2 years
Fair
before all the
before
COVID
all of
shenanigans
that.
happens.
Yeah,
Yeah.
yeah. Cool. So, well, now that you know, in retrospective,
Mm.
um, what would be your advice to, let's say, anyone who is in college or around that, looking for job? What should
Right.
they keep an eye on if they are just interested in embedded? Not necessarily, let's say, the fact that they want a job in embedded, but just the fact that
Mhm.
they want to do embedded and be open to it in the future. What would you, or maybe
So
just
I would
your version,
suggest,
but
yeah.
2017.
I think with embedded you need to play with hardware. You need to have a board in your hand where
Fair.
you can plug things up, and you can have like an SD card plugging out, and you can add your software onto it and then plug it back in. I think that's very important.
Hmm.
You need, and if you have that boards for cheaper, I would suggest buy a few and try to make them work together and do something cool with it.
Oh,
Add a
cool.
camera module, maybe two camera modules, and they're talking to each
Right.
other somehow.
Right.
Um, so the I think what I'm coming from here is do projects, do very simple, very stupid, very useless projects.
Hmm.
It becomes very exciting very fast.
Hmm.
Honestly,
Right.
once, because
Right.
it's very daunting. You need all this nowadays with the modern embedded systems. You need so much background software, so much background knowledge of things.
Hmm.
It kind of becomes
Right.
daunting to get into it.
Yeah.
If even if I give someone some basic kit which already has a program loaded, and I say, hey, just toggle the LED on a button press, they
Hmm.
won't be able to figure it out
Right.
on their own if they're scared of it.
Right.
But if I tell them one pager, hey, go here, do this step,
Hmm.
and then improvise yourself. So play with the
Right.
hardware, improvise, and then the ideas will start flowing. You will
Hmm.
be able to dive into schematics, into programmer's guide, into
Right.
register layers. You will be able to learn to use debugger after that, maybe.
Hmm.
And
Hmm.
yeah, just keep experimenting, keep doing things, keep building shit for yourself.
Hmm.
And I think that's the best way to enjoy embedded right now. You
Fair.
have so much hardware to play with. You have so much free knowledge out there, so much new hardware to experiment with.
Hmm.
You can't be bored with it.
That is
So
true.
just getting started is the biggest thing, I would say.
Fair. And how much would you say? Uh, how much would you rate Ordino as a starting point? Well, starting point, or just rate Ordino as a whole in terms of.
Um, I haven't used it myself that much, honestly. I have an
Okay.
ARPI.
Fair.
Uh,
Fair. Fair.
I
Fair.
have an ARPA in front of me, but there are a
Hmm.
lot of undergrad folks who are very fast on Arduino now. So going by that metric, I would say it's probably easy to just pick it up and start playing with it. So
Fair. Hmm.
uh, I don't think I can give a rating here because I have not personally
Okay.
used it that extensively yet. Even
Hmm.
the RPI I have is probably collecting dust somewhere. And the reason for that is because I am in the industry, I kind of
Right.
get to do all these things
On
on my
other.
job.
Right.
Yeah, making yeah, and making other very cool shit. And
Fair.
there are many projects that I want to do, and that's why I actually bought an RPI. But yeah, I just couldn't find the time to
Okay. Fair.
you
Fair.
know go and experiment with it. But I liked
That.
it, honestly. RPI, the
Fair.
starting of it, I would give it 5 out of 5. It was so easy. Their website to get started on it,
I see.
the
Okay.
background software that they have, just I mean, it's so easy. You can just download the thing, just click on program, and it will do it for you if you have the right things
Right.
connected.
Fair. 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 So they
After
have
that,
like the.
yes, you have to figure it out a lot. But
Hmm.
yeah, they have a quick starter guide, which is pretty good.
Okay. And then, if I may ask, what was the project on RPI that you wanted to do? Just so that it's a starting point for somebody else.
Honestly, I really wanted to. first thing is play with it, see
Okay.
what could be done,
Hmm.
right? And my main goal was to ultimately attach a camera to it
Hmm.
and start doing some AR things on it. That was my
I see.
main motivation.
Yes,
Yeah.
yes.
So I kind of wanted
And
to do, yeah, a proof of concept kind of thing, which we have talked about before.
fair, fair. Yeah, I was going to
Yeah.
mention
So
the same thing for
yeah,
and let me go ahead now, which is for our audience or who is listening. So Ayush is super into augmented reality stuff,
yeah,
and we had I recall that when we were working together, like in a meeting room, we did discuss for too long.
yeah,
I mean, extended like 1.5 hour, I guess, or even more than that, in terms of how AR things can be done, and the ideas that you wanted to explore. And I believe this is now, for the same reasons, going back.
yeah.
And yeah.
So the art, I bought the art by after that discussion actually.
Oh wow. Okay.
I didn't end up doing a lot with it, but yeah. That's how much that's how inspiring AR is to me. I think if someone out
Hmm.
there is trying to start out in embedded, AR is probably not the way to go, I would say,
Ha, fair, fair. Yeah,
because it
that's
takes there's a whole new dimension of image
right.
processing of how you're supposed
Right.
to do things. Just setting up the image system for it is very interesting part of it.
Hmm, hmm.
But to actually have an AR product,
And
there's
that's
so
like a
much more
long
that goes
shot.
into
Yeah.
it that's outside the scope of embedded if someone is starting out. So
Right. That's
wouldn't
where
recommend it as a first project.
fair. Yeah. And, true, true. But now that we are on the topic, I just want to um, explore the complexity a little, if you're up for it. Which is, so the idea of AR would be that, and this is again for the audience, and maybe
Mhm.
this is a segue into, can GPU and the current work or the past work gets you towards your own final goal. So
Sure.
what I was going to put on the table was, okay, there is a camera, you're just receiving or asking for a feed into the RPi, but now the idea of
Mhm.
AR is to identify the subject, the signal, and the noise, retain the subject,
Yeah.
delete the noise. And oh, actually, I might have got that wrong. uh, Delete the noise is one thing, but then also you have some your own 3D image that you want to
Yeah.
project onto that environment. So
Correct.
maybe it's
Yeah.
it's less of a deletion and more of like a superimposition.
Yeah. Fair. I
Something.
mean, you can throw these terms around all day, but ultimately
Go ahead.
it's a virtual world projected onto a real world.
Hmm.
Um, and whatever it takes to get there is what you have to do essentially.
Fair, fair.
Yeah.
So I think once you have the image processing pipeline
Mhm.
set, let's say your application or your code is receiving that pipeline, then it's all,
Mhm.
I think the algorithm then just deals with, okay, here's the video feed that's constantly coming in
Okay.
from the camera, and we want to
Mhm.
send it to some sort of a screen. It can be like in front of your eyes, or it can be a display, and
Yeah.
between the incoming stream and going to the video buffer, the algorithm then takes over, and that seems more like a computer science problem where you
Yeah.
actually yeah,
It's
then there
more
is
of
no
an
more.
algorithms problem, I would say.
Hmm.
Computer science deals with, in my opinion, I'm sure there
Hmm,
are
hmm, hmm,
better
hmm,
experts than me who will correct me very soon.
hmm, hmm.
But I think computer science in itself should deal with what are computers capable of, right?
I
How
see.
can you make something faster? How can things be organized around things? Networking should come out of computer science, for example. Trying to
Okay.
creating a protocol over a network should come out of computer science. Um, Image processing, of course, a computer scientist can do it, but the thing is, it should come out of algorithms. Algorithms is a big
Okay.
part of computer science for sure.
Right.
But I would bet that someone working on image processing algorithms full time will do a
Can
much better job of optimizing it
then
than a computer scientist. So these two people need to
agree.
come together
Right.
and then say, hey, this is my algorithm which is optimized mathematically. How would you design
Implement.
your computer to
To
make it
cater to
faster
it.
on your hardware. Yeah.
Fair.
Um, so yeah, so it's a both kind of problems. But if you're talking about it from an embedded system point of view,
Hmm.
I think our job as embedded engineers is a bit limited in this role right now because a
Mm-hmm.
computer scientist will imagine an architecture which works well for the algorithm. The algorithm guy will figure out what kind of algorithm
The
should be run, which will
mathematical
give us
stuff.
lower
Yeah.
latency. As an embedded system person, I think our job is to maintain the system, not
Right.
in the sense that maintenance also not in the sense that product is out. Okay, we are looking at maintenance updates, security updates. Not that. What I mean is, the computer scientists told us that this should work, right? Embed guy will come in and say, hey, maybe I need this kind of power for this to work. Maybe I
Right.
need this kind of bus to make it work. Maybe an RTOS will be better to manage this kind of state machine,
Right.
and things like that. So there are like trade-offs that now these three have to do to
Mm-hmm.
figure out what kind of things should be hardware designed, what kind of things should be software designed, what kind of things
Mm-hmm.
should be embedded domain design principles, right? And then the embedded guy is supposed to make sure that the computer science works on the algorithm and it works on the device that you have,
Hmm.
and then maintain its repeatability.
Right.
That's where embedded systems comes in. Because
Right.
computer science will tell us, hey, this is possible to go from A to B. Um, Algorithm will tell us how to get from A to B. And embedded will make sure that every time we start from A, we end up at B. For example,
Fair.
if there are memory leaks, we are supposed to stop them.
Hmm.
If there are power constraints, we are supposed to walk around them. So we
Right.
should be able to go from A to B always. That's what an embedded guy would do.
Right.
That's my opinion. Of course,
No,
there are
that I
different
think
kind of sharing that can happen, but yeah,
right. No, true. I think I'll just upvote that, and so it's more of keep the system stable and ensure that you can port the same software from one hardware to like an improved version of the same hardware.
yeah,
When the CPU, well, if the CPU numbers change, it's the embedded guys who figure out, how the same set of applications and the algorithms can run. So yeah, I would upvote to that. So
mhm,
then, now slowly moving towards your current role.
yeah,
So maybe briefly talk about what happened at Google, or your time at
mhm,
Google, and then time at ARM, and then how did Apple happen? What attracted
right.
you, and all of.
So
Well, you need
I
not.
think
By
I
the
think
way,
I'll give
heads
a
up. Hmm.
brief. Yeah,
Sure, sure.
go
I
ahead, go
was
ahead.
going to give a heads up. No company secrets,
Yeah,
and nothing proprietary. Yeah,
yeah,
anything that's
yeah.
generic. Go ahead.
I think I just I think it's looking back, it feels very natural for me to be here right now, but looking back, it doesn't really feel that natural because I
Hmm.
started up in, let's just say it, I started up in Java
Hmm.
as an internship where I was doing machine learning stuff.
Right.
I came from that into controller MCU side embedded, where it was just one controller on an RTOS environment working on something.
Right.
Switched over from that to bare metal on an SoC, where you
Hmm.
wouldn't think that a bare metal would exist. And then I moved on to MCUs again, but completely coming out of CPU and SoC world and going
Hmm.
into GPU. But apparently it didn't matter because we were still doing just firmware for GPU, and this is at
Right.
ARM, by the way.
Right.
We were doing firmware for GPUs, which is again just an Cortex M in there, which is doing all the stuff. So my knowledge from CPU world could still be applied in the GPU world, but it
Hmm.
gave me an exposure to, hey, there's a whole completely different kind of
Right.
architecture out there, and GPUs are insane. They're like a completely different beast.
Beast.
Honestly,
Okay.
after 2 years working in GPU, I still I'm not sure I can still explain it as intuitively as I would explain a CPU.
Okay.
There's just so complex to get your head around. I'm still
Okay.
learning
Hmm.
myself, but it's fascinating. And because I was doing firmware in GPU, now I am in a place at Apple where I can do kernel drivers for GPU themselves,
Ah.
where now I'm more into the GPU space than before, ever before. Of course, my CPU knowledge and my SoC knowledge are still there because the GPU
Right.
is in an SoC, so you need to know. how
Right.
and your code actually runs on the application processor now. So it's not running on GPU. As a
Hmm.
kernel developer, my code doesn't run on the GPU. It makes sure others' GPU code runs on the GPU
Right.
while my code runs in the application processor, right?
Right. So
So,
it
uh, yeah.
Mhm. Go ahead. Go ahead. Go ahead. You complete your
So,
thought.
so, so yeah. So it's like slowly I've been like being pulled away from the CPU world and being pushed into the GPU world. And it has taken, this is my fourth job now, I think, in
Mhm.
last 8 years.
Mhm.
So yeah, it kind of takes 4 years to put your foot in, and then
Mhm.
another 2 years to be knee deep in it, I would say.
Wow. It's very interesting. You have completed 8 years. Wow, man,
Yeah.
8 years is a it's a long time. And also,
I
I
think
should
7, but yeah, 7.5, I would say.
7.5, 8. Fair, fair, fair.
Right.
You know, I was going to mention that the whole exposure thing, I think that really helps. So you went from like working on MCUs for DLP, so
Yeah.
that gave you like some ground to work in, productively work in, or
Mhm.
ramp up. Then you could use that know-how to join us at Google. And then we
Yeah.
worked on MCU Baremetal firmware for like, well, we continued to work for maybe 6 to 8 months after you left. And then the
Right.
three of us left for other teams
Yeah.
as well. uh, but then the the fact that a GPU has an MCU,
Yeah.
that really helped. And then I believe I recall from our previous conversation that the resource management firmware on the
Mhm.
GPU is where you were. So you are again
Yes,
on like
exactly.
a stable footing in terms of, okay, I can be useful because of the MCU, but hey, let me
Right.
look at what the GPU is doing. Right.
Exactly. Because you need
And
to know, right, what kind of
yeah,
resources GPU has and what kind of
definitely.
workload it
Oh,
can take in.
absolutely.
So you have to go ahead and, I mean, and you're curious.
Yes.
Coming from CPU, you're very curious. Why are GPUs all the rage right now?
Right.
What is the special thing that they're doing? You're very curious about them.
And
So you get to know. Yeah.
very, very true. And in fact, I think the reason I relate to whatever you quoted is because I have, well, my own career and my own positioning has been same. When we were doing, let's say, the power management firmware, well, I was just talking about me. Like I was looking at the rest of the SoC and trying to learn, okay, where is what and why is it placed that
Right.
way and how does it talk to. And I
Yeah.
think we were very fortunate to be on that central piece of the puzzle or
Yeah.
the complexity. Anyways, so now you go on to doing, or well, resource management team for the GPU. And this is, I think, a good place to be in for anyone, that you have something that you know about, that you can contribute to, that you
Right.
feel you know 70-ish%, 50 to 70% confident, because there is some
Yeah.
learning to be done. But then you're getting
Mhm.
exposed to something brand new,
Yeah.
right?
Exactly.
And now what I see happening in your case is you're back on the CPU. So all of that A
Yeah.
class
Yeah.
CPU, here and there,
Mhm.
itsy bitsy data points or nuggets of information, more reasons to solidify those, let's say. Or
Yeah.
whenever you run into, let's say, the CPU folks. Well, just a
Mhm.
moment. What happened? Okay, never mind. So you want to go out? Fine, you can go out. Just a moment. Let me just hide myself
All right.
and
Yeah.
ask my wife to leave. Okay. Well, I'm sorry for that.
Welcome
Well,
back.
sorry in the sense. Yeah, thank you. So, last time we were recording, and she tends to, sit in the same room and work. So she
Mhm.
crawled
Oh
to
yeah.
the exit. Then she was seen in the video. That was so funny.
I don't know if I can pan my camera using
Yes,
something.
yes,
What?
yes, it is. It
Maybe
is.
not. Uh,
Yes, yes,
that's
it
my
is
daughter.
following you. Oh, hey, that's Cosmos. Ah,
Yeah, he's
nice.
Cosmo. He was
Cosmo.
crawling around earlier as well. So
Ah,
so
okay. Ah,
we both have
okay.
companions. I'm not alone in
Yes,
the world.
yes. Man,
Yeah.
so
Yeah.
you got a black dog. Very good. Yeah, I love black dogs. Well, for whatever reason, I called Cosmos. I don't know. I just
Weirdly, a
remembered
lot
it.
of people do. You're not alone in that. Yeah, even my
Feels nice.
concierge in
Okay.
this building, he calls him Cosmos, and I don't correct him. I'm like, yeah, go on, man, whatever.
Yeah,
And he loves
okay.
it, so I'm like, yeah, why not?
Why not? Yeah, fine. You got two names, one with the S.
Oh, there's someone who called him Cos, just that. They never figured Cosmo, so he just wags his tail and goes to you. So
Man,
call
such
him
a cute
whatever,
name.
honestly.
Nice. Such a friendly dog.
Yeah.
Well, that reminds me just arbitrarily, we might travel over to Europe. And if we do so, well, I'm
Yeah,
thinking
I'll
London
be
would
there.
be a pit stop. Yeah. Yes.
Even if it's not, if it's Europe, I can make up a stop in Europe. Don't
Oh,
worry
wow.
about it.
Okay. Okay. Fair, fair. I'll keep you posted. Fine. So going back, and where were
Yeah.
we? Well, the fact that
Uh,
you're back on the
yeah.
application processor and the kernel driver thingy. Well, now you can reason better given the background. Right? You have some idea of how the SoC is laid out. You have some idea of how the application
Yeah. Yeah.
processor. And
Yeah.
now I believe, like in 2 to 3 years, if you want to pick a niche, then that would be a time. I believe so because I'm in that process now where I have to put my
Mm-hmm.
finger on something and be like, okay, you can
Right.
call me an expert of X. Luckily,
Right.
between us, uh, the team I moved to, I'm doing a lot of low level kernel internals stuff.
Mm-hmm.
So
Nice.
whatever happens before the drivers load and take over, yeah, I'm involved in
Yeah.
that. So we'll compare notes and you know, yeah.
So, for context, everyone, I have never worked on kernels.
Yes, that I well,
So this
neither
is
of
so
us.
so this job, right? Apple.
Hmm.
And honestly, this one specifically, getting this job was kind of a dream come true for me.
Oh, go
Um,
ahead. Tell
the
us in
the
details.
reason was, yeah, because I've been doing firmware for 7 years by this
Hmm.
point, and by the time I had done 4, 5, maybe 6 years, basically when I was done with 1 year in ARM, I
Hmm.
kind of got a feeling that
Hmm.
I mean, for myself, I need to be growing up now, right?
Yeah. Hmm.
Firmware was still exciting, firmware was still good. You can still find new challenges in different kind of products.
Hmm.
But me doing it for 6 years personally, I
Hmm.
just felt I need to go up a bit. So I was kind of
Fair.
looking into other software roles, or maybe
Right.
going up the stack into the kernel, right?
Right.
My challenge was to find a team who was
Hmm.
okay to take such a senior guy, train him up to work on a kernel when he has not done it before, right?
Hmm.
And
Hmm.
it is a challenge, to be honest, but
Right. Right. Fair.
it's doable. It's still a challenge. And the way to do it would be as do your own projects, maybe create a profile, create a kind of a background on GitHub where which you can
Hmm.
rely on that, hey, I've done
Hmm.
things in kernel, I
Some
have worked on
proof of
Linux,
work.
some proof of, yeah, basically. So my version of that was to do trainings. ARM provided trainings on Linux, so I
I
just
see.
went ahead and did those, right? Got the context, and then with my Raspberry Pi, which I got for AR, I was assuming I could do experimentations in Linux,
Hmm.
and then keep uploading them to GitHub.
Hmm. Hmm. Hmm.
Um, so that was my plan of action to get into Linux more, kernel more, or the other way would be to find a team, as I said,
Hmm.
which I did
Hmm.
now, right?
Internal.
So I was
Yeah.
just starting to pivot on it, and actually I was using your platform to get
Hey,
started on it, to be
nice
honest.
plug.
And yeah, no, I really was. I mean, with
Sure.
the
Sure.
all the interview prep, I did it from embedded pajamas, so in pajamas.
Glad.
So yeah,
Glad.
um, and uh, and then I got this opportunity and I was really, really shocked that I got a call back because I had it very clear in a resume. I could have lied. I could have said, yeah, I know this. I can do it.
Got
but,
this.
but I didn't have it on there. I
Yeah.
had it in bold in my resume. Hey, I've done RTOS here. I've done, what do you call,
For
bare
me.
metal here. I've never done Linux.
Hmm.
But yeah, I think they were very keen on the fact that I have been in GPU for 2 years now.
Hmm.
And um, I guess the whole interview process was judging my fundamental concepts on OS and my
Hmm.
fundamental concepts on embedded, of course. But mostly,
Right.
it felt like they were really heavily asking OS stuff because
Right.
they wanted to make sure, even if I haven't worked on it,
Hmm.
and I probably not don't have scalable, ideas of how to build scalable
Right.
systems in that context, whether I can reason about it or not.
Right.
Whether if they tell me something, I'm able to pick it up or not. Whether I
Right.
can say, hey, yes, I am familiar enough that if you say a word to me, I won't be a
Right.
blank monkey. I would know that it means something and I would know how to engage with it. I would know how to take it forward. I
Right.
think
Right.
I was fortunate enough to find a team who could focus on that aspects in an interview
Right.
and judge that ability for myself.
Right.
And so I honestly just prepared the hell out for it. And amazing team, honestly.
Nice.
Loved having conversations with them. And yeah, eventually when I got the job, I was talking to my would-be manager when I had not accepted it. And I once again called him up and I said, hey, listen,
Are you sure?
very, 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 very daunting. Never
Yeah.
done this. I don't know how the wrap up would be. Are
Hmm.
you sure? Yeah, exactly. That
Yeah.
was, I never said, are you sure? Of course, but that was my feeling
Yeah.
going to
Yeah.
that
The
call.
one liner
And
that
yeah,
summarizes.
but that's the good thing about good people in tech, you know.
Yeah. True.
I think Google itself took a very big call on me.
Hmm.
When I joined Google, I had
I think
only
that's how
done
all of us feel.
I guess maybe. I had no idea about SOCs. I
No.
had a very limited view of embedded from TI. I mean, it was a
Yeah.
very big view, but I never
Yeah.
dared to look past it. So I was like,
Right.
yeah, this is what embedded is. And I had this
Mm.
very narrow view of maybe there's nothing else, and I know everything about embedded now, so I can go anywhere. Google taught me no, still a lot more to learn, still a lot more to
Right.
do. And they were still, and basically you and the team were still making a bet that, hey, I can teach this guy, he can do it. And yeah, I think
Right.
that's what's great about having good people around you. Um, and
Yeah.
that's how you can hop industries, honestly. Finding people like that who will help you along the way, who will teach you along the way, that is the way to hop industries. Or you build your own projects. That's another way to do it. Oh, your voice went away. Yeah, I can hear you. Wait, did mine?
It might be mine actually. Can I rejoin? Let me rejoin. It might be mine. Really? Yeah, still doesn't work. Can you hear me? No, I can't hear. So when I run a video, it works for me.
Hello.
So
Yeah. I
yeah, now,
think I'm back.
yeah,
Nice. So I think I have no idea how many seconds we lost.
have good audio technology. Uh, something to think about maybe. Someone out there, please create good,
Try,
video
please.
chat platform. which
Yes.
doesn't confuse if different devices are connected and switches randomly to another one. I think.
Well, in I have no idea what happened in my case.
Yeah.
I have a dock on which a wireless receiver is connected, and
Right.
I at least I couldn't see the green. What do you say? The spectrometer, whatever
Okay.
audio level.
Yeah.
Anyway, so what point did you stop hearing me?
I think
Or
as
well,
soon as you
or
saw, like I stopped talking and you started, I didn't know what we were starting at. So I was talking about having good teams to hop around. Yeah.
ah, and I was mentioning that personally, what worked for me, what has been working for me, like I think I have also hop team like every huh, on an average of 2.5 years. I believe the SOC team at Google was the longest I've been on any team, 4.5 ish years. But rest just hopped within like 1.5 to 2 years. Anywho, but the point about exposure, I think I resonate with that. The I don't know how it works for other people, but for me to be able to self navigate, I feel I need to know a lot more outside of the current subjects to be able to reason on my own. If not, then I end up asking too many questions to my immediate senior, be a bottleneck for all the progress, and then feel so bad about that. So it's like, yeah, please fire me. On that note, I well, my so the person who hired me as an intern at Intel, recently I'm kind of connected with him again, and it's been like few months we are going back and forth, and this time we sat down and talked at length, and I did not feel as much useless as I was feeling back as an intern. So I opened up a lot more. He got to see a different side of me. But then, I did tell him that back when I was an intern, I felt that I was like absolutely useless and I had no idea why they were letting me around.
Yeah.
But then his perspective was, well, you were one of the most productive interns that we had got. And I was like, wow,
I learned this recently, uh,
okay.
that um, it's very easy to
Mhm.
see other people do better than you
Yeah,
and think you're not doing the same level of work.
yeah.
On the other hand, what they are looking back at is what you're doing versus what they were doing when they were your age.
Yeah, yeah. Fair point. Fair point.
I recently
Yes.
learned this because I recently went through, well, not recently, that recent, like 4 years back, maybe 3 years
Okay.
back. I kind of went through the same thing where juniors are coming into the team, and I
Hmm.
could see, hey, they are being a bit shifty because they think they're not doing well.
Ah, yeah, yeah.
While when I was in their place, I was maybe half as good as they were being, honestly. And these were like superstar
Yeah,
freshers.
yeah, yeah.
And yeah, I mean, that was my wake up moment. Hey, you can do it. It's fine.
So,
It's okay. No one is comparing apples to apples. They're
yeah,
comparing apple to a very old apple. So all good.
yeah. I think the imposter syndrome, right? And the fun fact I believe is once you accept that fact that nobody knows everything, but what matters is like the um, honest intention and effort to learn it, or just be open to the fact that hey, there are pieces of this that I want and others I absolutely hate. I won't accept those pieces. I think that's fine too.
Yeah.
Just acceptance.
No, yeah, I think that's a very big thing. I've tried, at least, I don't know if I have how successful I've been, but I've always tried to stay humble in how much technology I know and I'm expert of.
Oh,
I
I
don't
would.
think because I
Hmm.
started on TI, right? Kind of got a bit confident that hey, if I built a whole module,
Hmm.
I know everything about it. 6 months later, someone asked me about it, and I had already forgotten,
Hmm.
right? So
Fair.
I'm like, even if I knew everything about it at one point,
Forget
that's
it.
temporary. That's temporary.
Yeah. Yeah.
Even if you're an expert about something, you can't remember
Yeah.
everything,
True.
and it just doesn't make sense. to question someone who's coming at you
True.
and saying, hey, maybe this is wrong,
Yeah.
and you're like, no, I am the expert. No, that doesn't make
None.
sense. You
Yeah.
go in,
True.
you look at whether it's wrong or not, and then you
Yeah.
create a reasoning whether it's wrong or not. And
Right.
then you explore it together so that both of you learn it together again.
Right.
Just,
You,
yeah.
while you were describing this, in between, I had this urge of just acknowledging what you rightly quoted it about yourself, which is, I feel you have a very good sense of what you know, what you don't know, and I feel you're very comfortable with it. And part of the reason I believe, some people fake it, and I think,
Mm,
and maybe faking is like a defensive mechanism, which is, I
maybe.
mean,
Yeah.
you know, they're just maybe not wanting to be vulnerable, and I'll
Mm,
blame it on the environment around them, that they
mm.
are not, let's say, they haven't gotten enough deliberate or
They're not
bad.
comfortable coming in and saying,
Fair.
hey, let's explore together because I don't
Fair.
know.
Yeah, fair. Or, hey, I just don't know. Right.
Yeah.
Forget the exploration. It's,
Yeah.
yeah, yeah. Lights good. uh, I would blame the environment and not the person. But also, I think, just looking back and cherishing the four of us as a team, I feel, personally, I feel the best thing was that we all somewhere where we knew our limits in terms of what we know, and we were very vocal about saying, hey, this is what I know. uh,
Yeah.
Beyond that, it's like, yeah, let's figure it out together, or let's see what
Yeah, and
happens.
I think extending that, I think that's the way to make great products.
True. Agree.
Um,
I believe that. Yeah.
Even if you're doing a project, even if you're making $1 billion a year product, that one thing, let's as a team, let's explore it together. Even if you
Goes
know
a long way.
everything,
Yeah.
exploring will give you a new thing.
Yeah.
Um, that will make a better product in the end of the day.
True.
Because I got really inspired because of the team at Google that we had. We would just book a room and just flip through a book.
Yeah.
I'm like, what? I mean, it was an Cortex M architecture book, I think, if I remember
Yeah. Yeah.
correctly.
Yeah. Yeah. Yeah.
And I'm like, this guy already knows Cortex M. Why is he flipping through the book?
But again, that was your reference. So the way I would look at it is like, okay, let's see if more details come out.
And
And
they
personally,
did come out. I mean,
it
yeah.
did.
So
Yeah.
that was a very big learning moment for me because, as I said, from coming out for TI, I was like, no, I know stuff. And yeah, that was a very big learning moment. And I've kept it at TI. I learned a lot, honestly. I mean,
Fair.
because I learned so much, I thought I know everything because there was
Ah.
so I learned so much. Honestly, that blessed that team. They held my hand through everything.
Wow.
They had the patience to explain things to me. It was
Hmm.
pretty cool. Coming to Google, it was more like now I'm
Hmm.
holding my hand, and then a whole team is hugging me, and then we are we are
Going
walking.
in whichever direction. Yeah.
Yeah. So that was I mean I had experience of both the environments, and I think
Yeah.
the amalgamation of it is just perfect.
Right.
Because you also need to be somewhat confident in what you know. It's not like
True.
you question everything. If you know 1 + 1 = 2, and then Ramanujan next day comes and says, "Hey, sum of infinite series -1/12," um, you know, there's both ways going around it.
Yeah.
But 1 + 1 = 2 will help you more in most
Then, yeah.
cases
Yeah.
than
Yeah.
-1/12.
Yeah. Yeah.
So,
True. -1/12. Just a moment. Let my wife in. So, all right. She's in. She's out of the frame. Done. So 1 - 1/12. Ramanujan 1 + 1. That helps a lot. Yeah. Well,
yeah.
mhm.
Mhm.
Go ahead. Go ahead. Go ahead.
And I was just saying that so coming to my experience of getting into Apple, um, honestly, I said that last time and I would still say it again. I have been very lucky in my career so far.
Mm-hmm.
Whether I got the job or not, luck played a role. Whether I found good teammates or not, luck played a role. And most of the time, I was very lucky. Most of the time, I was very lucky in that sense. But
Mm-hmm.
I
Okay.
recently came along this very good quote. I don't know, it might be some movie or some video
Okay.
maybe.
Okay.
But I think because people always talk about skill versus luck, and the quote is, um, your skills should be good enough for luck to matter.
Yeah.
And
Yeah.
that's
That is so true.
such a good quote.
It's
Just
a good
boils,
one.
just
Yeah.
finishes the skill versus luck conversation for me.
Yeah.
You
Yeah. Yeah.
can't
Yeah.
get there without luck, but you need your skills ready to for the luck to
Yeah.
matter. I mean,
Yeah.
that's just beautiful. So I would say
Yeah.
every opportunity I got, I tried to upskill myself in something.
Hmm.
And it
Hmm.
was not deliberate, right? It
Hmm.
was not a game plan or master plan that I was playing.
Right.
It was, I found something interesting.
Mm-hmm.
Um, can we build something in it? I found something
Right.
interesting. Can we learn more about it?
Right.
And that was my upskilling, you could say. And
Mm-hmm.
then, as luck would have it, Apple was hiring for that skill. As luck would
Right.
have it, ARM was hiring for that skill. As luck would have it, Google was
Google
hiring for
was
that
hiring for
skill.
that skill. Fair.
So yeah, so in that sense, I do, from my experience, you can't game it. You can't game, hey, I'll learn this, so I'll get
Hmm.
this job.
Right.
You really have to come it as a take it as
Right.
it comes, basically, and
Right.
just stay curious, just keep upskilling. And it's not a hustle to upskill, it's just curiosity. If you're curious in
Right.
something, upskill in it. Don't think, hey, I need to upskill in it, I need to upskill in it. That will be exhausting.
Yeah. Right.
Just be
Right.
curious and you will be all right, honestly.
Fair. Be curious. Keep your eyes and ears open, and you'll be all right. Also, do you think the fact that you were you were looking for you were open to looking for opportunities that also played like improved your luck, so to speak? Because if you don't try, then you don't win anything. But if
I
you try,
also
you
like
may.
another quote on this. It's
Yeah.
called luck is a numbers game.
Uh,
So,
fair.
so if you are going to, let's say, um, roll a dice and
Hmm.
you win a game if you get four on it,
Hmm.
you are going to win more often if you roll it 100 times rather than 10 times, right?
Fair. Yeah.
Um,
Pure statistics, yes, and
so
probability.
so you can game luck a bit as well with
Hmm.
numbers, which
Fair.
also means you're opening yourself up to a lot of rejections. You're opening
Yeah.
yourself up to a lot of self-doubt and a lot of calls going neglected, not coming back at you.
Right.
Ultimately, you just have to remember that's where you say it's not skill and it's luck.
Hmm.
You really need to figure out where your luck played a role, where your skill played a role, and that
Right.
also keeps you humble, honestly. The way that we were talking about, whether you know things or
Yes.
not,
Yeah.
recognizing where it was luck and where it was skill is part of it, I
Yeah.
would say.
Yeah.
It's just that you can increase your luck if you just
Yeah.
increase your numbers.
And
Ultimately, yeah.
mhm. Well, I was going to mention, I think rejections are a good thing because
Mhm.
they really, really force you to kind of meditate on, well, you're not as much of a smarty pant that you think you are, right? If you are, what happened? Why did you get rejected? I think that's where
That's
uh, it
that's
forces you to
kind of
be humble.
fair in certain situations. I was more coming from a dead reckoning kind of way that hey,
Okay.
you're just fresh in the market looking for a job.
Hmm.
Um, if you got to a last interview and then you're getting rejected, yes, your thing
Oh
definitely
yeah.
completely aborted there. But if
Fair.
you're dead reckoning, if you're just sending out resumes and then you're getting like one call out of 100,
Oh, it's just
that's
can't say.
where I was saying
Hmm.
it's
Hmm.
more luck than your skill, I would say.
Fair, 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 fair. Okay. I
You
was
still
not
need to
thinking of it
upskill. I
that.
mean, you still need to have a banger resume. You still need to game the AI selective system. You still need to think how you present yourself and things. It's not
Right.
like, yeah, it's a ratio. Do you want the skill to? There are things where skill will take away from luck. There are things where luck will take away from skill,
Fair.
and you always have to be on it.
Fair.
Where your skill matters, where your luck matters. Skill you can control, skill you can manage.
Yes. Fair. There are
So why
controllable
not give your
things.
best in that
Yeah.
and
Yeah.
then leave
Fair.
the rest for luck to do?
Fair. And I was going to revisit back just because I think I had a conversation along the same lines, which
Mhm.
is, hey, like I was telling my mentor, so to speak, the person who hired me as the intern. I was like, look, I wrote 10 lines of C code prior to you interviewing me. Of the 10 questions you asked me, maybe I answered six and a half, ballpark seven. Uh, and then at least I knew my own abilities in terms of how much C I know. Forget firmware.
Right.
We're
Mhm.
not going there.
Yeah.
And the first thing I had done after getting selected in that interview was go look up what firmware means. Fair.
Yeah.
So, and at least he told me that there are a lot of things outside of just pure tech or
Mhm.
pure technical things that at least he and a bunch of others, and I would agree with him because that's my state as well. Uh, there are so many things outside of tech that matter. For example,
Yeah.
being able to talk with someone.
Mm.
The like one is, well, the junior perceiving you know more than them. In
Mm.
reality, might not be true.
Yeah.
You might know um, some pockets of information here and there. They might know some pockets, but then somewhere the junior has to accept you with your flaws as well,
Mm.
for them to listen and buy in into your
Right.
vision or whatever direction, right?
Right.
The second is there are things that they don't know, but then they should be willing to at least hear you out.
Yeah.
Like if they start questioning back too much, saying, "But I read it this way in the textbook, that way," fine.
Mm.
We can debate on that. But then 6 months of the 8 month internship went in debating.
Right.
So
Yeah.
so what I'm coming to with all of this is, I think, just my observation of you. Uh, I think you are very accepting of other people's ideas to the point that you let them, finish with their flaws and try and catch the end goal. And then you also try and fill in the blanks for them. And I think that fill in the blanks somewhere conveys that, hey, if we are in a leaky boat, Ayush has an idea that it's a leaky boat. And then he
Yes.
also, because he could complete my statements, oh, okay, it's leaking from X place, Y place, Z place. The fact that he could also talk about the leaks
Yeah.
convinces me that maybe he'll be able to help patch those, or at least try patching.
Yeah. I think
Guys,
everything. Yeah. Good. Sorry.
oh, I was going to conclude by saying
Yeah.
maybe the kind of technical conversations you have, in
Hmm.
spite of you believing that, I think you understand what the role needs, then you
Right.
place yourself there and then you say, I got some fraction of it.
Yeah.
And maybe these guys are not seeing it, the ratio. But the fact that you could see the bigger requirement and
Mm-hmm.
picture, I think and I'm I'm decently sure on this actually, maybe the interviewers could see that.
Mm.
And then it's like, hey, you know the perimeter here. All we have to do is pass you the information you need
Yeah.
to be able to see and maybe operate as we do. And then, hey, doesn't matter you don't have experience in drivers.
Yeah.
We are
That's
here
the
for you.
thing. I think. Yeah. That's what I think great teams do. Or
Hmm,
if
okay.
you're anyone out there building a team, I would say yes. I think sometimes products need to be churned out faster, so you need someone immediately on the
Yeah.
job. But if you can be a bit smart about it, if you can say, hey, maybe plan it earlier so that you don't in a crunch,
Hmm.
it will always pay off more to get
Hmm.
someone who can walk through a
Hmm.
conversation with you on something technical
Hmm.
uh, than someone who knows on day one how to do things.
Yeah.
That's my experience. It's more
Fair.
enjoyable to work that way as well because you haven't shared interests and you can
Right.
talk to people. I think it's a very, I don't know, it just came as an idea to me, but it might foray into a lot of in office versus work from home debates as well, I think, because
Fair.
because now that companies are prioritizing that, hey, get things out faster, it's easier for people who already know how to do things work from home,
Hmm.
and the office environment is dying. On the other hand, if you had a team who would like to explore things, who would like to build things, I think they will themselves choose to be
To
in
get
office
that.
to discuss
Yeah.
something.
Yeah.
Uh, and
True.
yeah, it's I don't know how true it is. I just
No,
I don't
sure,
know.
sure. A
Maybe.
hypothesis. Yeah, fair
Yeah.
point, fair point. I
Um,
was, uh,
mhm.
sorry, go ahead, complete your thought. I'm really
because
sorry.
because I enjoy coming to office for these conversations.
Hmm.
If
Fair.
we are just coming to office to have meetings, if we're just coming to office to have lunch with each, I mean, lunch is enjoyable, but still, if it's just
Yeah,
lunch and then
yeah,
just going back to your desk, I would pick work from home.
yeah.
But if we are discussing things, if we are making a road track together,
Hmm.
I would very much like to be in an office.
Fair
Um,
point.
I think.
Com- yeah, 100%. I think I agree with that. I would want to be where the exploration is happening, and the more random the exploration, the more meaningless it sounds to begin with. I think the more interested I am in general. Uh, while you were mentioning about when you have like two mm, two rookies or two uh, noobs,
Pressures,
let's say,
essentially.
yeah,
Yeah.
freshers, yeah, or people who are not too experienced about a certain
Mhm.
topic, discussing with each other
Yeah.
with a common goal of wanting to learn more. I think that's
Mhm.
important.
Yeah.
Would you? What are your thoughts? Because I'll present mine, and then what are your thoughts on that? I feel the freedom to be vulnerable increases between both parties because they know that the other person doesn't know enough about the subject anyways,
Yeah.
so we are trying to fill in the gap for each other, and then let's see
Right.
where we go. So it's
Fair.
guaranteed that at the end of the conversation both of them know more than what they already knew,
Correct.
or
Yeah. Hmm.
if both of them couldn't add anything meaningful, they at least leave with more meaningful questions to be explored, which now
Yeah.
both parties can explore separately and maybe
Hmm.
meet again over lunch at some point, or another discussion, and then say, hey, I read this, I found out this video, I pumped into this senior who told me XYZ, and this story that we built, okay,
Yeah.
these parts are correct, and these maybe still need to be explored.
Right.
I think somewhere, if you are talking to an expert, then at least if I imagine myself there as the rookie or the not so, learned, then I'm hesitant on opening my mouth because I know I'm
Mm.
either wasting the other person's time or I'm
Right.
going to get severely judged to the point as to, hey, wait, I can't believe I'm working with this guy.
Right. 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 No, I know this is a very classic, like the imposter syndrome thing, right?
Yeah, yeah.
Um, so my take on this is very simple. I think I would put it in two ways, right? Given that you have a good team, I mean,
Fair,
given that
fair.
I'm removing all
That's
the
the
toxic work culture
presupposition.
and
Yeah,
everything. Yeah,
fair, fair.
right. Given that you have two teams, you have two kinds of experts, right?
Oh, yeah, fair,
One
fair.
that you would actually waste time off because
Yeah,
they would
fair,
rather be more productive than helping you out. Two, who are better at training you up so that they don't have to
yeah,
work as much,
fair,
right?
fair. Yeah.
So, and I would argue that in both cases, is worth it to disturb them. The
Okay,
first one,
okay.
the first one you will take away a lot. They will, because what they will
Yeah.
do is they will tell you exactly where to go to find the information. And then
Hmm.
from now on, you know how to self explore. You can always
Fair,
go back, always trouble them
fair.
more, but you learn self exploring.
Hmm.
The other one, they're anyways happy to help you because you ramp up
Nice
faster,
person.
so you
Yeah,
help them back faster.
fair.
So in both these cases, given that you're in a good team, again, given that you're in a good team,
Right. That's the
always
base
be stupid.
condition. Yeah,
Always be stupid. I don't mind it. Honestly,
yeah,
if
yeah,
you're coming to me with a very stupid question that
yeah.
maybe in the first paragraph of the programmer's guide
Like
would
the
give you,
first line says.
I don't mind it.
Yeah,
Come to
fair,
me, I will guide you through it. I don't
fair.
care because
We,
that's the kind of environment that I want to be working in.
True.
Because I find myself in this position where there are experts and I want them to be approachable.
Fair,
So
fair.
why not be the one who caters to that culture and build that culture in the
Exactly,
team?
exactly.
Now,
You
when
know,
it comes to the toxic areas of the work culture, honestly, if you're someone who subscribes to the way we are doing things,
mm,
the culture that we want, you can't survive there. You
yeah,
won't survive there. So you're going to leave anyway. Why not leave with more knowledge? Disturb them still.
fair
Disturb them
point.
still,
Fair
right?
point. Yeah, fair
Yeah. So
point.
there's never any reason to stay back and think I might be wasting
Mm,
someone's time. Someone's
true.
time wasted for knowledge gained is overall time gained.
Fair.
That's my equation to it.
No, fair. I
So yeah.
think I learned a perspective here. Uh, True. At least in my, well, I tend to not do that now, but I tend to talk to the experts and then tell, like upfront, tell them, hey, I'm stupid in this department, and we might discover that I'm also stupid in the claimed expertise department. But just letting you know that I wanted to learn more about this, and I have found that usually people are willing to help, and I
Yes.
think
Yeah.
they come from that majorly from that second angle, which is helping somebody else just helps you in the long run,
Yes.
right?
It's a very big
So,
thing. I mean, I am a very big beneficiary of myself because I train the fresher, so I don't have to work. I,
fair, fair, fair.
right?
You can do other unknown things. You can
Yeah,
explore other
because you can
territory.
focus on larger and larger problems. That's how
Def-
you increase your throughput.
True.
And investing in that 1 year training someone up is absolutely worth it. For anyone
Yes.
out there, it's
Yeah.
absolutely worth it.
If
Um,
not anything, it exposes you to your own the holes in your own knowledge. Right?
yeah.
One question that your junior asks is like, "Oh, wait, what? Yeah, that's too basic." And wait, I don't have a good answer. In fact, I have none. So true. Well, going back to it's been like I think an hour
Yeah.
plus. Okay, so this is a good podcast, or well, at least for those who are still around, thank you. Going back to the GPU things,
Yeah.
just so that we have some technical takeaway also. What was the view of the GPU like? Like what you thought it is, and how did it turn out? And again, subject to the fact that you quoted earlier, it's too vast.
Yeah.
So I'm not suggesting that you explain like the architecture of,
Right.
but in terms of what your perception of or view of the
Mm.
GPU right now is, could you just share that?
Getting into GPU from like ever since I've been hearing GPUs, I've only heard one thing. It's just smaller CPUs duplicated.
Okay, fair point.
I've always heard that, right? But I
Okay.
never knew what it meant. What do you mean it's just
Hmm.
smaller CPUs replicated? We can replicate CPUs elsewhere as well.
Hmm.
Why is it a different thing? And it's not just that. It's it does have smaller CPUs inside replicated. It has a compute engine inside. Um, but it's wired in a way, it's the data path that the data takes. It's very different in the
Hmm.
sense that in on the same memory, different parts of the GPU can be working. Um, in this, not well, that's not very accurate, but
Oh,
for
fair.
a
It's your
layman's
view
term,
of the
right?
world. Yeah, it's your
Yeah.
view of the
So
world.
ultimately, what I thought was, it's just a special way of ingesting a lot of data and putting it out there,
Okay.
which is true.
Right.
But GPUs are now hardware designed to do certain tasks faster, right?
Right. Fair.
Well, it's not just saying that hey, the same computation that CPU does is faster because it replicates it. No,
No.
it
Okay.
has hardware changes on it, which caters to different things which a graphical processing pipeline would want.
Hmm.
You want to have 3D objects coming in. You want to have a list of them. You want to know if some 3D objects was overlapping something else on a 2D
Right.
plane. You can't
Right.
see it. So it will be faster to calculate it on a GPU than on a
Hmm.
CPU.
Right.
It's wired differently, is what I would say. And
Fair.
in that sense, it has its own different kind of challenges. On CPU, you would think, hey, command, 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 command. I have it into a register set, and one program has its own context, and yeah, based on the context in the stack.
Fair. Yeah.
GPU is a bit different. It's a bit more complicated because it has a lot of things depending on a lot of previous things. It has a lot of staging pipeline done in it. In CPU, we have pipelines as well, but
Yeah.
in GPU, it's like you can select the different bits of the pipeline to run as well. It's not like it has to come through all the pipeline. It can go into the middle bit
Mm,
and then go
okay.
forward and
Okay.
then go back to some other pipeline because it's depending on that.
Wow.
So
Okay.
it's a different kind of, and different companies or different architectures do it differently. I would also say
Fair. Fair.
there's something called immediate rendering. There's something called tile based rendering. So it's a
So on
completely
and so
different
forth.
thing.
Fair. Fair. Fair.
What big thing that caught me off was the stack of software
Hmm.
required to get a CPU to do things efficiently is
Hmm.
much smaller, or
Wow.
in case of like the height,
The
not the
layers.
width,
Yeah. Fair.
the
Fair. The
layers. Yes,
layers.
it's
Yeah.
much more on a GPU because on a GPU you will have your graphic libraries like Vulkan, CUDA, or any other thing,
Hmm.
right? OpenGL, things like
GL
that,
or things like that. Yeah.
and then you will have a language which is the graphics language that would be used to use those libraries. So, like I think Apple has Metal.
Hmm. Hmm. Hmm.
That's the
Hmm.
language you would code your GPU programs in, and then there will be your actual application who needs to have those parts of course and need to invoke it to figure out what needs to be done, what doesn't
I
need to be done,
got you.
set up a
Yeah.
scene.
Yeah.
Then
Yeah.
there will be a user mode driver who will figure out those memories for you. Then there will be a current mode driver who will figure out other memories for you. And then there will be a firmware which will do other things for you.
Right.
So it's just so much stacking going on. There's so much
Right.
things linked to each other
Right.
that it's often very difficult to, for me at least. GPU
Uh-huh.
experts are really like really fast with these things.
Fair.
But for me, it's very difficult to say with confidence, hey, maybe that's an error in that layer. Maybe that's
Right.
an error in that layer. I don't even know yet which layer will affect things in what way.
I
There
see. Yeah.
are
Yeah.
in CPU, you have, if you go, it's basically syscon drugs.
Hmm.
I would say in
Hmm.
CPUs we have simplified that by using RISC processors, right?
Hmm.
Intel does this still interlates RISC. I've heard. I'm not
Hmm.
sure if it is or not, but
I've heard similar
GPUs are
things.
that on
Yeah.
steroids. It's
Fair.
just do everything. Give me one command, this will do everything for you. You don't have to think about which register is going where. You don't have a registers
I
to
got
overload.
this.
Just give me
Fair.
one command, one assembly command equivalent can fire a whole pipeline.
So
And
the
yeah,
this is very interesting. So going back to your initial comment, which is GPU is like a lot of small
yeah,
CPUs together, kind of. Uh, my understanding lately over the past few years has been that uh, I kind of reduced it to maybe it's not like a complete CPU, obviously, uh, but the core of the CPU, which is do add and multiply fast.
mm,
And I kind of arrived at that idea because, well, if it's doing a lot of image processing or DSP for that matter, right, 2D, two-dimensional DSP, then the signal processing is very heavy. Digital signal processing is very heavy on
right,
add and multiply. So I just
yeah,
thought that it would do a lot of that. And then my version of what the firmware on the GPU does had to do more with, hey, let's say if there are multiple incoming jobs of
mm,
render this image, render that scene, color this XYZ,
right,
then maybe internally it's allocating resources saying, you 500 guys are going to take care of this one task,
right.
you 10,000 guys are going to do this whatever other thing. But yeah, based on the details you shared now, it just feels as though that is more likely. Like one command and it will say, okay, I got the rendering. Sure, I'll go read the memory. 10,000 people will read different bytes
Yeah.
of the memory and we all will work in parallel to give you that answer.
So from an ARM experience, it looks more like you will set up a command. So you will have different
Ah,
So in CPUs, you would create a command table,
Fair,
and you will have your own way of encoding it.
fair.
In GPUs, it's hardware supported. So the hardware determines what a command does. So you still have
Wow.
smaller assembly-like stuff where you will set up a command wherein you are set. The GPU also has registers like CPU has.
Fair, fair, fair. Yeah.
Set up values in the registers, which is essentially creating your command, and then you can send
Hmm.
an instruction, run this command. So it will go into
I
the
see.
registers and figure out what the command is. And that's how, with the one instruction, you can fire a whole pipeline because that command means something. And these are like very complex,
Fair.
very big commands. Um,
Understood.
and all the commands will have their own, not all of them, but whichever is required, will have their own address space to work in. So you will, like, as part of the command, you will figure out what the input address space is, what the output address space is. And then
Ah, understood.
where does the command come from, right? So the idea would be that um, the host, which is your application processor driver, will essentially set all these memories up, will give the command, will set the command up based on what has been asked for it to do.
Mm-hmm.
The library gives a context to the driver that, hey,
Mm-hmm.
this is what we want to do on this data.
Mm-hmm.
This is the parameters of this data. So the host will have a layer which will create that command and then send it over to GPU. The firmware doesn't know about it. The firmware doesn't care what the command is. What firmware gets to know is, and this is coming from ARM world, okay?
Mm-hmm.
Other
Fair. I
systems do
mean,
different
that's
code.
how they chose to do it. Fine.
Yeah,
Or
uh,
maybe it's one of the open techniques to do it. They chose that. Fine.
exactly. So for the firm, because I know more about firmware than what kernel does, I'll
Fair.
limit it to that. What firmware will look, the command can request, can have its request resources as part of it. Like suppose it wants to run a certain kind of shader, which means
Mm-hmm.
let's say you want to do a compute job where it actually doing just one person is able to,
Mm-hmm.
but a matrix compute job kind of thing. So it will need that shader resource, that compute resource, which can do the compute. There are different kind of systems.
Mm-hmm.
Something can do a fragment job, something can do a geometry job, something can do a compute job. The
Mm-hmm.
command will tell you that it needs a compute job. The job of the
Uh,
firmware would be to see that it won't even
the
care
reason.
actually. The command will request it of the hardware. The hardware will say, send a signal to the firmware. Hey, this is requested, and then firmware will figure out whether something is free or not. If
Ah,
it's free, it assigns it to the command. If it's not free, it tells
it
the
just
command to
parks
wait.
it. Hmm.
It
Fine.
passes it basically, yeah.
Wow.
So that's how a GPU firmware works. It doesn't really know what's happening. It just knows what is
Uh,
requested from the hardware and what is currently running on the hardware and what are the priorities of these requests.
I
That's all the
see.
firmware knows.
Fair. So
And yeah,
it's
that's how
it's
it
just
manages it.
fair, fair. So it looks as though, at least in this current case, it was. And I've heard something similar for other GPUs. So I'm thinking it's kind of generic, wherein the resource manager then is just given a task that it knows nothing about, like with the end goal, so to speak. It's just doing the bookkeeping for the resource, saying, "Oh, you needed these many free tiles and this much internal SRAM memory. Okay, I see that 10 other guys are busy and we don't have it this much.
Yeah. So the
Whatever you need."
internal MCU in ARM GPUs won't even do the memory management. I mean,
No,
in
fine.
the
I'm
future
just
version,
saying,
they might. Yeah.
fair, fair.
But
Well,
that's how limited firmware is in those things. That's how the host is figuring out. The memories
mm,
are encoded into the command. The hardware directly use that address. Firmware doesn't know about that address.
I
Firmware is
see.
just supposed to fire those commands onto some hardware. The hardware figures it out itself. So that's how custom it is. That the hardware can do the memory work for whatever it needs, right? It
Fair, fair
needs, it
point.
knows the context of everything. So hardware is very complex. In
Yeah, yeah.
CPU, you need to tell it, hey, go to that
Hmm,
memory, get this out, add this, and go back.
hmm.
In GPUs, it's all basically, I don't want to call it hardware state machines, but it's like more complex hardware, which is kind of sentient.
Okay.
It's not really
Fair,
sentient, but
but feels
it
as
does a
though.
lot of heavy lifting for you, which a CPU might not do,
Fair, fair,
basically.
fair point, fair point. And I think the CPU world is limited by the fact that there is an instruction set architecture which is the contract between software and hardware. And
Oh,
maybe some,
actually, I have a very good. So you know how MMUs can be implemented in the CPU, right?
yes,
Theoretically, you could implement an
yeah,
MMU in your application software itself,
fair, yeah,
right? But MMUs are specialized hardware. They will do the table walk for you. You just need to set
right,
up the right config.
right,
That's how GPUs work, but like
hmm.
very big. Like
Very big,
they
fair, fair,
have
fair.
this configuration for graphics. You can just tell them to do something and they will do it.
It feels somewhere like a DMA capability with some other capability of doing add multiply with some other
Yeah,
capability of managing things in the pipeline
yeah,
with some 10,000 other
right,
capabilities
yeah,
GPU.
yeah. So essentially, whatever acceleration they could do for graphics, they
Hmm,
made a custom hardware for it
fair,
and put it
fair. It was somebody's promo.
in.
Let me
I mean,
add this
Nvidia
capability.
stock price, I would say, would be a bit.
Fair, fair. But I think that anything that's it. I think the general pattern has been any use case that shows up again and again. For example, there was a time when Ethernet was a software implementation. Way back in time, I think 70s, 80s, whenever. And then it was used so often that it made sense to just implement that as a hardware.
Yeah,
Right?
yeah.
So same with UART, same with SPI.
Same with graphics. I mean,
Same
we
with
were
graphics,
building
exactly.
graphics on CPUs, right?
Yes,
Yeah.
yes. For all we know, and again, we are here, talking obviously rookies. You are less of a rookie than I am in this case. But for anyone who is well versed with the graphics world, might actually come up with a natural design which looks like the GPU. It's like I need this, I need this, I need this, I need this. Separate
I'm
state
sure.
machines done.
Yeah, I'm sure they can do it.
Yeah.
The people I worked with in graphics,
Mhm.
they are on a different level of understanding of these
Fair,
things, honestly.
fair point. Yeah.
Especially the people who are working on performance optimizations on these things. Um,
Next level.
the,
Yeah.
I don't even understand how to do it, honestly, and what they do. I mean, if you're giving, give, you're, if your task is to, let's say, increase the efficiency of a certain algorithm because it's being used more in games now.
Hmm.
So you figure out basically that the command you're about to generate for it, which resources should it ask for in what way so that it's faster.
Faster.
That's their
Yeah.
job, right? And that's not it's not only this. They do like they like
Well,
performance, they
multiple
do
such
power, they
stuff.
do a
Yeah. Yeah. Yeah.
whole of thing.
Yeah.
That's just one example. And I'm blown away that you need to know so much. You need
Yeah.
to know what the game engine wants from you. You need to know how often it's going to ask for it. You need to
Yeah.
know how often you can actually run it on the GPU. You need to know whether you can group it or not. And you need to know what the hardware is capable or not. You need to know whether it can thermally do it or not.
Right.
You need to know all the data pathways. Can you take an alternative one? Maybe that section of the GPU will be faster.
Right.
It's bonkers. Yeah,
It's
there's
a
a lot to learn, honestly.
yeah game of Jenga, right? You carefully take something out of this critical balance and then optimize.
Yeah.
So
And GPU
cool.
performance is all that. It's like the industry is using this algorithm more now. Let's optimize that on our GPU.
Ah,
That's what
okay.
it is.
That's okay. Okay. So the market research is around what's getting used more, or what kind of algorithms are trying to leverage the GPU capabilities, and then we must be ready with performance numbers for that.
So
Okay.
they're doing it
Perfect.
together basically because even the people coming up with games, also designing the games,
Collaborate.
also need to know what's in the hardware, so they can use maybe one API which is faster than the other one,
Fair
and
point.
get the same results.
Fair
And
point.
then, and because it's graphics, sometimes you can get away with a few things, a few pixels here and there are fine.
Yeah.
So you also need to know that threshold that hey, maybe even if I use this, better performance, worse results,
Uh,
good enough worse results. I don't care.
yeah. Yeah.
So
Perception.
it's a whole industry which I don't natively understand yet. In CPU, we are so much concerned about getting everything right every time. In GPU, that's also true, by the way, but it's a
Right,
very
but
at very high level where you can start ignoring a few things.
yeah,
Um,
a shade of red is like slightly here and
they
there, no
obsess over
problem.
FPS a lot. I've seen
Yeah.
like point 0.2 of an FPS is very important apparently.
Wow.
Um, so yeah, it's as I said, so much to learn still, and I'm so excited that I'm in this industry now
Nice.
because people are. I'm more interested. I'm not that interested about GPUs. I'm more interested in the brilliance that people showcase
Yeah.
around me. That how much they know in this all of the stack. I
Right.
just moved from firmware one level up to kernel. There are other people who are moving from graphics to kernel, and our languages don't meet.
Yeah, yeah, yeah.
We are
The
speaking
kernel
two
is
way
the
different
only
things.
common thing. Yeah.
They have the same challenges. Coming down to kernel is also the
Right.
same challenge as, for them as is from me to co-op. So that's how
Right.
complicated GPUs are.
And I think that's also opens or makes that field an even playing field in some sense. Again, going back to the analogy of, two rookies about the kernel trying to
Yeah.
explore, and along the way, you learn more about graphics, and the other person learns more about, let's
Yeah.
say, firmware. And together, you learn some more things about kernel.
Very fair. That's how I'm going to be performing at my new job. That's the view I'm taking.
Well, just sharing like a fun fact, that's how it's going for me. So
Ah,
and again, I feel blessed to be at the current team, which is everyone's so supportive and helpful. Also, I found that I can be useful to the team also here and there. So every once in a while, I feel nice, and I thank them. They feel nice, so it's going good. And I'm imagining it's going to be same for you. Yeah.
I hope so. I mean, so far it looks very nice, not gonna lie.
Yeah.
And I'm glad that you found a place where you're able to learn as well because I felt like at least at where we were in CPM, I don't know if I'm supposed to say that word or not,
So that's
but
fine. It's fine.
but um, but it felt like you knew a lot more than that job needed you to know.
Okay, I am glad that that was the perception. So I
Um,
honestly felt, just sharing it now, I felt that that space made more use of what I already, or let me demonstrate what I already knew. And so I bargained time against that.
mm,
So I took care of a lot of other things in my personal life by being able to answer the questions in least amount of
right.
time, let's say, or
Yeah.
you and the other two would often end up doing uh, a lot more. And the moment I felt that, hey, now I need to extend out to the entire SoC, and there is like a
Mm,
huge learning curve coming my
right.
way, I felt there were other things in life that needed my attention. And so I was like, okay, I'm going to moonwalk out of this place. I handed it over to Rajat. Rajat fantastically took care of everything. And it took
Mm,
me 2 years to find myself another fun place where I
mm,
feel like I'm
right.
growing, being useful and growing, uh,
But isn't
technically and
that just
non-technically.
true technically? Like, because
Mhm,
leadership at that point,
mhm,
you had like three rookies just handed on to you,
mhm,
and you had to support a whole hardware validation team with just that. With whatever
mhm,
technological prowess you might have had at the time, that was
mhm.
certainly a very new challenge. And I think, at least I feel like it went really well. I don't know
Fair
if it
point.
was your first time doing it or not, but yeah, it was pretty cool actually.
Well, I think it definitely wasn't first. I have worked with, let's say, folks junior to me.
Mhm.
What the common thread was, I think I learned in past how to give the other person enough reasons to just collaborate and cooperate towards a
Right.
common goal. And I think between the four of us, well, we know what all we, you know
Yeah.
what the barter there was. But I was very lucky, and I'm very thankful that the three of you chose to trust me in whatever shape and form. And I think we had the most fun. I was
Yeah,
just
I
telling
would agree.
someone met me day before yesterday. We took like walk during the lunchtime, and they happened to have seen like podcasts and things like that. So that person was like, I could not stop myself from telling them that there was a time and we were the only team
Yeah.
which would just decide to go on an outing randomly, just get it from our desks and leave, not bother about work. But that only has happened just because I believe the kind of team we were. So
Yeah. Looping back, great teams matter.
yes,
Honestly, make or break a product, make or break a life.
yeah,
Great teams matter a lot, I would say.
definitely.
Find
But
your great team, guys. Honestly,
yeah,
it's very
and if
important.
you, well, I think the bottom line that has helped me is if you are not able to be yourself and be useful to the current team, yeah, find yourself in other place. Right. But yeah, that's
I mean,
that, and
both
I
our histories kind of point that both of us do that. So,
yeah, exactly. At least I do very heavily, and it looks like you do that too,
yeah.
pretty much. I've hopped, yeah, 5 in 9.5. You have hopped like 4 in 7.5. So fair. We're keeping the run rate. Cool. So I think it's been I think an hour and a half that we are
Yeah.
talking. What I would prefer we do right now is maybe conclude this one, and maybe for the next one, I think I'm very interested in just taking some guide on GPU and then just like flip through, much like how we used to do it, and then just
Yeah. Yeah.
randomly explore which part is what.
Oh, I would love to. That will help me so much as well, actually.
Sure.
No, that will be fun. That will be fun. I want to do it.
Fair. So let me return back to you in terms of when we can do that, and I'm very much wanting Mohammed to join us also,
Yeah.
because
Yeah.
then it all of a sudden takes a very interesting technical turn based on the kind of questions he asks. Cool. So then let's conclude this for today, and let's meet again, and then do like a dive in terms of okay GPU internals. Fair.
Sweet.
Perfect. So I'll go ahead and stop.
Mhm. Thank you for
Uh,
having me.
yes, and for
All right.
those who are sorry, those who are still around, thank you for sticking around, and yeah, see you around next time.
Yes.